Isosceles triangles are going to be a big deal for us because there's lots of things that are special about them that we need to keep in mind as we work problems. Just knowing that a triangle is isosceles will make us able to do a lot more things with it in our problems. So an isosceles triangle, I'm just going to draw a picture and then label it for these vocabulary terms right here. But an isosceles triangle has like a triangle, and it has two sides that are congruent, and the sides that are congruent are called the legs. So I'm going to mark these congruent.
Miss Farah, please dial 4500. Miss Farah, 4500.
These are the legs of this isosceles triangle because they are congruent. So we've got two congruent sides. Those are the legs. The vertex angle is the angle that is formed by the legs. So up here at the top, just going to label it, that is the vertex angle. Then you have the base. The base of an isosceles triangle is the third side. It is the side that is not congruent to the other two sides. And then you have base angles. The base angles are the congruent angles that are on the base of the triangle here. And I mean, this triangle could be turned, but these angles, you find them because they are opposite from the congruent sides. So these base angles are always across from these congruent sides, and they're congruent. How you mark an angle congruence with this little arc here. So this is a base angle right here and here. So your base angles, they are congruent to each other. The legs are congruent to each other. The base is the side that is not congruent to the others, and the vertex angle is the angle that is not congruent to the others. So let's look at a couple of rules here. We've got the base angles theorem. And the base angles theorem can be used in proofs, especially in pre-AP class. We'll be seeing this in proofs. But the base angles theorem says if two sides of a triangle are congruent, then the angles opposite them are congruent. So if you have two sides of a triangle that are congruent, then opposite from them, these two angles will also be congruent. The converse of that theorem, we know what a converse is. It switches the order of a statement, switches the order of an if-then statement. You can see the if and the then in this statement here. So it goes in reverse order of what I had just put. So if two angles of a triangle are congruent, then the sides opposite them are congruent. So just the reverse order. If these two angles are congruent, then opposite from them, these sides will be congruent as well. The corollary to the base angles theorem says if a triangle is equilateral, then it is equiangular. So it's kind of like this up here where this has two angles, so the sides across are congruent, but this one has all three angles marked, so all three sides across from the angles are congruent, which means that they're all congruent. So this corollary says if a triangle is equilateral, then it is equiangular. Which you probably already remember that from middle school.